Now this is general protocol for sequence data analysis. 1. Choose a set of related sequences. How we can perform the phylogenetic analysis based on a sequence data. What type of data, whether you are using the 16S RNA, 5S RNA, protein sequences, protein means enzyme sequences, you can work out with the protein sequences also, or even if you are ITS region or you have the SSR or VNTR regions sequences, or maybe the gel electrophoresis. Gel electrophoresis data is similar type, so you can assume that SSR or that band patterns as a restriction or RAPT data types. Okay. Now if you have the sequences, then choose a set of related sequences. As I have given a 16S RNA, we can work with 16 as well as the 5S. I told you ki 1200 is not enough, you need a complete 16S RNA length now. Okay. Otherwise what will happen? So okay, you have a conserved region, means if you got a 1200 of total length, 1200 base pairs of 16S RNA, that may create a problem. You have seen, so okay, neighborhood joining and UPGMA, the clustering between the mycoplasma and streptococcus. Okay, that was bit one species has been replaced, or that has entered in different cluster. Then multiple sequence alignment. For multiple sequence alignment, try to use a high gap opening penalty and high gap extension penalty, so that you will get a maximum alignment or matches conserved regions and minimum gaps for that, because that also affects scoring, or that also affects the alignment of the pair, that also affects the alignment of each sequences, or that align the columns or each character in particular or similar characters. That's the thing, because if there is a error, what happens in multiple sequence alignment, you have gone through, Miss Sangeeta madam also told it. Okay, one by one the pairwise alignment will be done, a score will be calculated, then a tree will be drawn, either neighborhood or by I think that's so. Same thing, circular logic, that's what I am telling. So okay, tree will be drawn, again multiple sequence alignment, and same will be used for again drawing means calculation of distance matrix or that method, and tree will be drawn again over there. So that pairwise alignment, if there is a error in case of when your progressive alignment, one sequence then second sequence pair, they will be aligned accordingly, the gaps will be matched or that will be adjusted. Then third sequence, next close, if there appears a error in first alignment and second, that will be transferred till the end of the alignment. So whatever MSA you got, that won't be final alignment. So it may be that may not be the optimum alignment. What is the optimum alignment? Where you have the maximum alignment score as well as maximum matches over there. So that is the optimum alignment. So that then strong sequence similarity. Now it's a condition, if there is a strong sequence similarity, if it's more than 60% or more than 70%, then if yes, then use maximum parsimony method, because parsimony method based on what? Parsimonious site or non-informative sites. Informative sites where you can cluster the organism into different groups. If that site is, on that site all the characters are same, okay, you have seen the multiple sequence alignment, if that column all the characters are same, so that is not an informative site, because it will cluster all the groups or all taxa into one group. So we want a site which is informative, means we should be able to cluster the taxons in separate group. That's the purpose. So if the similarity is high, then use maximum parsimony, whether it's a protein sequence or 16S RNA or means any nucleotide sequence you are working with, that. If no, or clearly recognizable is similarity. Now depends. I have given a sequence of Staphylococcus aureus. They all belongs to means Firmicutes. There are three classes are there. So okay, Bacilli, like Clostridae and the Mollicutes. Now in that so there is a high similarity in them. So maximum parsimony method is a good one. I can also go for a DM and distance matrices and also maximum likelihood method. Now clearly zones means if I go for another bacteria like cyanobacteria, that's a bit, or if you go for a 16S RNA for another distantly related bacteria, then go for distance matrix method. That is also if you find a clearly recognizable similar, means if the similarity is in between the 25% to 60% in that range, or if above 40 to 65 range, then use distance matrix method. Which method should be? But if you are using maximum likelihood method, when the similarity is 40 above 60%, you try to use both this method. But when the similarity is below 60% and above 25%, then don't rely on the MP, maximum parsimony method, but that time distance matrix method and maximum likely. And if the similarities means highly distantly related sequences are there having lesser than 25 or 30% similarity, then always maximum likelihood method is the best one. Now if you are working means like chymotrypsin and that subtilisin example, then or if you are working with 5-sRNA or some particular sequences of like legmoglobin and hemoglobin, okay, so that is very distantly related. So one is plant and one is organism, so that times to better maximum likelihood method may be used. Or if you are working with kinase diversified enzymes with different substrates, so that also. Or even if you are working with 16S RNA 5S, because it's a multi-gene family of ribosomal RNA, okay, by splicing mechanism. So that time also you, if you are taking a diversified organism, so better use the maximum likely. Then validate the results. It's not better you have the results by using all the methods, compare the results then. How you are getting? You should know the morphological features of that organism. Phenotypic data is very essential if you are working, though you are working at molecular level. Without the phenotypic characteristics, you can't correlate. I've given a notes one paper, that is morphological morphometrics. Morphometrics means phylogenetic analysis based on morphological character and phylogenetic based on molecular data types or sequence data types. Both are given, both are important, but anyhow you are working on a molecular data, but you should have a good knowledge of morphological. There should be a discrimination at morphological level also. Okay, so that's validate. You can now combine different methods for consensus. You can also, for getting a one good tree, you can combine all the methods. That is the. Now this was the 16S RNA nucleotide sequence that I used. I told you, okay, this is all, this row contains the neighborhood joining and this contains the UPGMA algorithms for tree drawing. In this case, F84, Kimura, Jukes, Cantor and log data used. Do you find any change over here? So okay, color is changed there, but blue. So all mycoplasma here, I am all mycoplasma here, mycoplasma. Only log data is showing changing just showing a change over there. That is in branch length. Then in Clostridium also, it has the same. This is the distance is same, 0.02, 0.02, 0.0. You have calculated this. Okay, the tree is same. What I can predict, what is the, what it means? Okay, so this is clustered. Clostridium is showing a more closeliness to mycoplasma. Okay, then this is Staphylococcus, same. But in case of log date, the Streptococcus, and Streptococcus has this out group of these all three. Where Streptococcus is same, just the tree is drawn inverted, means upper side, here it is lower side, but the same pattern is same. You find it's okay. Streptococcus is downward. यहाँ पे लगता है कि Streptococcus नीचे है या बाहर से गया, but it is same. Out group here means Bacillus and Staphylococcus are clustered together. Even Bacillus and Staphylococcus. Okay, here also Bacillus and Staphylococcus, because these are very closely related. So they are clustered. Then outgroup is Lactobacillus, is in the Lactobacillus order, Bacillus, or then Streptococcus is again outward because it has shown more closeness to mycoplasma or Clostridia. Clostridia is diversely means separate things. So you can. So this now see in case of UPGMA, compare the UPGMA and the this one neighborhood joining. Neighborhood joining, as I told, already you have studied. Yeah, even Urmila madam told you, okay, what it will draw ordinary tree first. Just a star-like structure, means everyone is evaluating at from the center point, and then it will progressively progress towards the evaluation or optimizing the branch length. I have showed you the equation how the branch length is optimized. So one by one it will go on optimizing the or calculating the branch length. So first tree is drawn ordinary, then it will go on. Now what happens in case of UPGMA? It go on clustering, progressive, means it will place first, this will be placed, then next closer one, then next Okay, this one, then these three will be closed, these three, then they will be joined externally. Means one by one the group will be added. That's why it's like appear like a cladogram. And see, this is appear like okay. So this is why neighborhood joining, some prefer neighborhood joining, because it gives the looks like evolutionary tree. Means they are sparse in the space. Okay, means they are scattered in the space like that. So where it appears like a cladogram. That's means this is the drawback. Means it's a look. Otherwise, the branch length here 0.5 is here and 0.02. Calculations are different if you are using. Okay, but the distance, all four methods they are giving like 0.02, 0.02, 0.02, 0.02. This tree. Means still the length there is very less similarity. Means less variation in the branch length calculation, or even in case of the UPLGM. Just this is the appearance. Now which tree you likes, that depends. Here also it's the same, just it has just made one change is in mycoplasma. Depends on some calculations, while because it has a evolutionary distance calculation method or different model. Okay, so this is the thing.